Welcome back, my relativistically rendered reality benders. I'm your quantum-superposed scientific storyteller, simultaneously condensing and expanding Einstein's genius across spacetime. You're tuned into a special bonus episode of the Multiverse Employee Handbook, where today we're celebrating the birth of a man who didn't just think outside the box, he proved the box was relative to begin with. Speaking of relativity, we've calculated that if you're traveling at 99.9% the speed of light, Pi Day would last approximately 22.4 times longer, giving you ample time to consume an infinite series of increasingly smaller pie slices. Though I should note that at those speeds, your apple pie would have the density of neutron star matter, making it significantly less appetizing, but extraordinarily more filling. But today, dear listeners, we're exploring the life of a patent clerk who revolutionized our understanding of the universe with nothing more than thought experiments and mathematical courage. That's right, we're celebrating Albert Einstein, born March 14th, 1879, a date that would later be recognized as Pi Day, because the universe occasionally enjoys mathematical coincidences. Picture, if you will, Germany, 1879, where a young Albert Einstein is entering the world with a head so unusually large that his mother worried something was wrong with him. Einstein family lore suggests his grandmother's first words upon seeing baby Albert were, "much too fat," proving that even geniuses aren't immune to awkward family introductions. Young Albert was not the prodigy you might expect. He didn't speak until he was 4 years old, leading some biographers to speculate he had developmental delays. When he finally did speak, legend has it he said, "The soup is too hot," displaying both a flair for observation and a lifelong tendency to comment on thermal states. Despite popular myths, Einstein wasn't a poor student. He was actually quite good at math and science, though he chafed against the rigid educational system of 19th century Germany. His real issue wasn't intelligence but authority. A teacher once told him he'd never amount to anything, presumably because Einstein kept questioning the fundamental nature of the curriculum instead of memorizing it. Young Einstein's first love wasn't physics, but the violin. He began playing at age 6 and continued throughout his life, often using music as a way to work through theoretical problems. At 16, Einstein attempted to skip high school by taking an entrance exam to the Swiss Federal Polytechnic in Zurich. He failed the general portion of the test, but did so well in mathematics and physics that the principal suggested he continue his education at the Canton School in Aarau, Switzerland, and try again. It's like being told you're rejected from a job, but should run the company's physics department anyway. After graduating, Einstein found himself unemployable in academia. Despite sending out letters to universities across Europe, no one seemed interested in hiring a brash young physicist with revolutionary ideas. It's like having a resume that includes planning to redefine the fundamental nature of space and time under your career objectives. Impressive, but not what most employers are looking for. After a string of temporary teaching positions and nearly 2 years of unemployment, Einstein secured a job at the Swiss Patent Office in Bern, evaluating patent applications for electromagnetic devices. This seemingly mundane job would prove to be the perfect environment for Einstein's theoretical work, providing both stability and intellectual stimulation. Plus, as Einstein later noted, when he finished evaluating a patent application, no one asked him to then explain space-time curvature to the management team. And so, With a secure job that occupied his days but left his mind free to wander the cosmos, Einstein entered what would become known as his miracle year. While most people's miracle years involve maybe getting a promotion or finally learning to make decent sourdough bread, Einstein's involved publishing 4 papers that would fundamentally transform physics forever. In 1905, while still working full-time at the patent office, Einstein published 4 papers that would change the course of physics. It's like revolutionizing an entire field of science during your lunch breaks, which makes your achievement of finishing yesterday's crossword puzzle during yours seem slightly less impressive. The first paper explained the photoelectric effect, proposing that light consisted of discrete quantum particles, later called photons. This directly contradicted the established wave theory of light and would eventually earn Einstein his Nobel Prize. Ironically, despite later revolutionizing our understanding of space and time, Einstein's only Nobel Prize came for what he considered a relatively minor contribution to quantum theory, a theory he would later question with his famous quip that God does not play dice with the universe. His second paper offered experimental proof for the existence of atoms through an analysis of Brownian motion. This may seem obvious today, but in 1905, the existence of atoms was still controversial among many scientists. It's like proving the existence of weekend work emails to someone who's never owned a smartphone. Obvious to us now, revolutionary at the time. But it was his third paper that truly shook the foundations of physics. On the electrodynamics of moving bodies introduced special relativity, showing that time and space are not absolute, but relative to the observer's frame of reference. The paper contained no citations and credited no direct influences, making it perhaps the greatest "I thought of this myself" moment in scientific history. Special relativity gave us the famous equation E equals mc squared, which describes the relationship between mass and energy. This deceptively simple formula, energy equals mass times the speed of light squared, contains within it the theoretical foundation for nuclear energy, nuclear weapons, and thousands of dorm room posters featuring Einstein's wild-haired visage. We must note that E equals mc squared is the rare scientific equation that has achieved pop culture status, appearing everywhere from science textbooks to the Big Bang Theory. It suggests this is because the equation has all the elements of a hit single. It's short, catchy, and nobody really understands what it means, but everyone pretends they do. While the miracle year would have been enough to secure Einstein's place in scientific history, he was just getting started. In 1915, he completed his general theory of relativity, expanding his earlier work to include gravity. Instead of seeing gravity as a force acting between bodies, Einstein described it as a curvature of spacetime caused by mass and energy. To test this theory, Einstein predicted that light from distant stars would bend around the sun during a solar eclipse, a prediction confirmed by British astronomer Arthur Eddington in 1919. When news of this confirmation broke, Einstein became an overnight celebrity. The London Times ran the headline, "Revolution in Science, New Theory of the Universe, Newton's Ideas Overthrown." It's perhaps the only time in history that overthrowing Newton's ideas made someone more popular rather than getting them expelled from physics class. Einstein spent the rest of his life trying to develop a unified field theory that would combine all fundamental forces into a single framework, essentially creating a theory of everything. He never succeeded, and his resistance to quantum mechanics put him increasingly at odds with the mainstream physics community. Some suggest this is why Einstein's later years are less discussed. His story contradicts our love of neat narrative arcs. We prefer our geniuses to either die young at their peak or consistently revolutionize their field until the end. Einstein's later scientific career, with its brilliant stubbornness and ultimately unsuccessful quest for unification, reminds us that even the greatest minds can be simultaneously right and wrong. Einstein's work wasn't just theoretical. It has profoundly shaped our modern world in ways both beneficial and troubling. General relativity isn't just an abstract concept, it's essential for GPS systems to function correctly. Without accounting for relativity, your smartphone's navigation would drift by about 10 kilometers per day, turning your quick trip to the grocery store into an unexpected tour of parts unknown. Einstein's work on the photoelectric effect laid the groundwork for solar panels, modern digital cameras, and advanced quantum physics. His insights into Brownian motion contributed to fields ranging from financial mathematics to climate science. And of course, E=mc² enabled both nuclear power and nuclear weapons, the latter causing Einstein great moral distress later in life. In 1939, Einstein signed a letter to President Roosevelt warning that Germany might develop atomic weapons and urging the United States to begin nuclear research. This letter helped initiate the Manhattan Project, leading to the atomic bombs dropped on Hiroshima and Nagasaki, something Einstein later deeply regretted. He would spend much of his later life advocating for nuclear disarmament and international cooperation. Beyond specific technologies, Einstein's work fundamentally changed how we understand reality. He showed us that space, time, energy, and matter, concepts that seem intuitively separate, are actually deeply interconnected. He demonstrated that the universe is stranger, more elegant, and more unified than our limited perceptions suggest. Today, Einstein's theories continue to be tested, refined, and expanded. In 2015, scientists directly detected gravitational waves for the first time, confirming a prediction Einstein made a century earlier. Black holes, another prediction of general relativity once considered purely theoretical, have now been directly observed and photographed. Meanwhile, physicists continue Einstein's quest for a unified theory, now through string theory, loop quantum gravity, and other approaches. The tension between relativity and quantum mechanics, the two great pillars of modern physics that Einstein helped establish, remains one of science's greatest unsolved puzzles. Einstein has achieved something rare. His scientific work is both practically useful and philosophically profound. His theories help your rideshare find you and simultaneously raise deep questions about the nature of reality. Few thinkers have managed this combination of practical application and philosophical depth. Perhaps Einstein's greatest legacy isn't a specific theory or equation, but his approach to science itself. His thought experiments, riding on beams of light, accelerating elevators, simultaneously moving and stationary trains, showed that imagination is as vital to scientific progress as mathematical rigor. He demonstrated that questioning basic assumptions, even ones that seem obviously true like the constancy of time, can lead to revolutionary insights. Einstein famously said, "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution." In an age increasingly dominated by big data and specialized knowledge, Einstein reminds us that the ability to reimagine reality is still humanity's greatest intellectual tool. As we celebrate Einstein on his 146th birthday, which also happens to be Pi Day, it's worth reflecting on what both Einstein and pi represent: the beautiful meeting point of simplicity and complexity, both appear simple on the surface. A wild-haired genius, a ratio of circumference to diameter, yet both contain infinite complexity and continue to reveal new insights the deeper we delve. Einstein was not just a brilliant physicist, but a humanitarian who spoke out against racism, nationalism, and war. He declined an offer to become president of Israel, supported civil rights in America, and consistently advocated for peace. His moral courage matched his intellectual bravery, showing that reimagining the world isn't just a scientific enterprise, but a moral one as well. He was also deeply human, enjoying sailing and violin, having a complicated love life, and often forgetting everyday details. The same mind that revolutionized our understanding of the cosmos reportedly couldn't remember his own address. It's a comforting reminder that genius doesn't require perfection. Perhaps most inspiringly, Einstein achieved his greatest breakthroughs not as an academic at a prestigious institution, but as a patent clerk working in the margins of the scientific establishment. His miracle year proves that revolutionary ideas can come from anywhere, not just from those with perfect credentials or institutional backing. So today, as we celebrate both Einstein and the irrational transcendence of pi, take a moment to appreciate how both continue to unfold in endless complexity while maintaining their elegant simplicity. And perhaps follow Einstein's example by questioning something that seems obviously true. You never know what revolution might follow. This is your quantum coherent correspondent, reminding you that, as Einstein himself noted, the most incomprehensible thing about the world is that it is comprehensible. If you've enjoyed this special episode, please share it with a friend who might find the universe more comprehensible or more wonderfully incomprehensible. And remember, in the grand cosmic lecture hall of existence, we're all still struggling to understand Einstein's equations. But that's exactly as it should be. After all, if relativity were easy to grasp, we wouldn't still be talking about it 146 years after his birth.